Hello, how are you? The topic of this video is
C++ Tutorial 3. Understand make unique for unique pointer. One of the greatest features brought by C++ 11 standard library is unique pointer. It magically manages dynamically created pointers with simple ownership semantics. To create one unique pointer for class A used in previous tutorial, you can use this statement. Create unique pointer P of class A using the keyword new and class name A with parameter value of 3. This is a program used in the previous tutorial on unique pointer. Run the program. Here is the output. No surprise. Comment out the original code to create unique pointer P. And switch to C++ 11 method to create P. Run the program again. It works as before. So C++ 11 has its own method to create unique pointer. Then C++ 14 standard library introduced standard make unique function, which is recommended for creating a unique pointer like this. Make unique with type A and parameter value of 3. Which one should you choose when creating a unique pointer? The answer is make unique. But why? There are 4 reasons that I know of. Before started, let me put 2 use cases in place. Case 1. Instantiate unique pointer in function call with old and new method. Case 2. Instantiate unique pointer and assign to a variable with old and new method. The first reason to use make unique is less typing. It may or may not be true. If you use it in calling function in case 1, it is obvious that make unique requires less typing. But compare creating objects with these 2 methods side by side in case 2. In this case, make unique actually requires more typing. The second reason to use make unique is no need to duplicate the type in one statement. Again, this is true when using it in calling function. Class A is only used once in the new method with make unique, but twice with old method. But they are the same when creating and assigning to a variable as in case 2. Both requires to use class A twice. If the above 2 reasons are debatable, then the third reason is more solid. Avoid using keyword new. These are case 1 and case 2. In both cases, new is required if not using make unique. This comes down to a bigger topic. In modern C++ programming, try to avoid using new. Why? Someone calls it bad practice, because when you use new, you have to make sure call delete at proper time to avoid memory leaks. Sometimes it becomes a bug because we are human and may forget to do the right thing. Sometimes it's hard, if not possible, because of exception or crash. We have to keep on thinking how long this pointer will last. Have I handled it correctly? Is it cleaned up in time? What if there's an exception? Program crashes. Your time may be better spent on algorithm and the task at hand, rather than all these details of housekeeping. Someone calls using new deprecated, because starting from C++ 11, we have smart pointers, including unique pointer. Using them guarantees that they will be deleted when they become useless. They have internal counter to tell how many times they were referenced. You see, on the one hand, the rule is to avoid using new. On the other hand, if we use C++ 11 method to create unique pointer, the rule has to be modified as avoid using new, except you are using unique pointer. All of these arguments lead us to one conclusion. Use make unique function. Hold on, there's a fourth reason to use make unique. It's exception safe. First, what is exception unsafe? Consider this scenario. Function foo is called with unique pointer, created using old method, and another function that may throw an exception. The compiler before C++ 17 is allowed to build the code in this order. First, new A of 3. Second, function may throw exception. Third, unique pointer of type A. If in the second step, the function actually throws an exception, then the newly created pointer to class A will not be deleted, since the unique pointer wrapper has not been created. The result is a memory leak. This is known as exception unsafe. Now, if make unique is used in calling function foo, not only it looks cleaner, but it's also exception safe. No matter what the order of arguments are compiled, pointer A will always be deleted, even though there is an exception. Note that in C++ 17, the exception safety issue is fixed. It can only have two possible orders of execution. The first one is new A of 3, unique pointer of A, function may throw exception. The second case, function may throw exception, new A of 3, unique pointer of A. It is described as the initialization of a parameter, including every associated value computation and side effect is indeterminately sequenced with respect to that of any other parameter. If you feel it's hard to understand, it just boils down to what is shown in this example. But if you are not using C++ 17, using old method is still subject to exception safety concern. Here is a list of the 4 reasons to use make unique. Less typing. Avoid repeating the type name. Avoid using new keyword. Exception safe. Some of these reasons are solid, some may not. You pick the reasons you like, but as a general rule of thumb, just use make unique to make your code consistent, and there's no real impact on performance. You use it for peace of mind. If you don't use it, you may get unpleasant surprises from nowhere. That's enough for me to indulge in persuading unbelievers to use make unique. Let's move on to understand a little bit more on the definition of make unique. Come back to our code. Right-click on make unique and select Go to Definition. There are 2 templates to define make unique. The first one is for non-array type with enable if t, not array. The second one is for array type with enable if t being array. I copied them here for easier reading. This is the definition for non-array arguments, with template function to enable if it's not an array as highlighted in the code. This is a definition for array arguments, with template function enable if it's an array. To understand the rest of the definition, let's first take a look at standard template. First, declare the generic type used in the template, my type. Then use it to declare function arguments. In this example, the function name is getMax with 2 generic type arguments, A and B. Then implement the function body. Return the maximum value of the 2 parameters using ternary operator. With the standard template knowledge at our disposal, let's go back to the definition of make unique for non-array arguments. It looks a little bit different. We can see the word template and the class type ty to define make unique function. They fit the standard template pattern. But what are those ellipses, 3 dots, and ampersand ellipses? Do they mean anything? Yes, they are part of Variadic Templates that are supported since C++ 11 standard. Here is one sample of the Variadic Templates. Suppose we want to create a function called func that takes a variable number of arguments and at least one argument, and pass these arguments to another function called sumFunc. This is how it can be defined. The first type is class first, which indicates there's at least one argument. The rest of class types for the template are declared with ellipses. Let's call them collectively with the name of rest. Now come down to the function itself with name func. Use rest type for all the arguments that this function may receive. The two ampersand and ellipsis symbol after the type is called DOM expansion marker, which means to pick one argument from args at a time. The pass function will be essentially expanded and passed to some func as first argument, the second, the third argument, etc. One more note before we claim victory on learning Variadic Template. The ellipsis operator in Variadic Template has two meanings. First, when it occurs to the left of the name of argument args, it declares a parameter pack. Second, when the ellipsis operator occurs to the right of the template or function call argument, it unpacks the parameter packs into separate arguments. After we understand the syntax of Variadic Templates, let's look at make unique function definition again. In the definition for non-array make unique, we see the familiar ellipsis and DOM expansion marker. We know what they are doing. But hold on, what is forward of types for args in the return clause? Forward is defined in type traits standard header file, used to forward an left value as an right value, or as either an left value or an right value. In our case, for make unique definition, you can read it as new of ty for args. That's all for make unique definition with non-array arguments. For make unique definition with array arguments, it's little bit simpler because the standard template pattern is applied here, not Variadic Template. I highlighted the key places so you can compare it with the standard template we learned before to understand more on its definition. This concludes our study of make unique definitions. Let's review what we have learned in this tutorial. First, 4 reasons to use make unique to create a unique pointer. Reason 1, less typing. Reason 2, avoid repeating the type name. Reason 3, avoid using new keyword. Reason 4, exception safe. Second, the definition of make unique uses Variadic templates that are supported since C++11. We learned these symbols: DOM expansion marker, ellipsis. Hopefully, what we have learned here gives us a good foundation to explore more features of unique pointer. In the next tutorial, I will show you how to pass unique pointer to a function by value or by reference. Thanks for watching.